Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we go through how to find the area of a trapezium. So if you've forgotten, a trapezium is a quadrilateral, so it's a four-sided shape, and it has one pair of parallel sides. So these arrows here indicate that the lines are parallel. So here, this line and this line are parallel, and down in the second one, this line and this line are parallel. So trapeziums sometimes have right angles, sometimes they don't. So trapeziums look like this or this. So make sure you understand what they look like, because you won't be able to correctly find their area if you can't identify that the shape is a trapezium. So let's go through the formula for the area of a trapezium. So what we're going to do is we're going to call this perpendicular height h. So here, h would be this height here. Remember, whenever you see h in an area or volume formula, it always means perpendicular height, the height at 90 degrees to the base. So we're going to call these two parallel sides. One of them's going to be called A and one of them's going to be called B. It doesn't matter which one. Doesn't matter if you call this B and this A. So how am I going to find the area of this shape? What I'm going to do is draw two rectangles. So I've started off by drawing a green rectangle that's a bit bigger than the trapezium. So this rectangle, it has h as its width and b as its length. So its area, the area of the big rectangle is just b times h, length times width. So now I'm going to draw a smaller rectangle that's inside the trapezium. So if I draw it around like this, so what would be the area of this rectangle here in yellow? Well, its width is again h, and its length here is a. So the area of the rectangle in yellow is a times h. So how we actually find the area of this trapezium is we take an average. You can see that I'm left with these triangles. It turns out the area of the trapezium is halfway between the area of the big rectangle and the area of the small rectangle. So to find something halfway between two numbers, what you do is you add them up and divide by 2. Now it turns out I can actually factorize this expression. So you've done factorizing, we did that in term 1. So if I factorize this top expression here, the thing that's common to both is a h. So I write h out the front, and then what do I times by h to get ah? Well, that's just a. What do I times by h to get bh? Well, that's just b. Okay? So I'm left with this. H times a plus b over 2. This is the formula for the area of a trapezium. It's the perpendicular height times by the sum of the two parallel sides, and then you divide by 2. And the way we got that, it's halfway between the big rectangle and the small rectangle. So you might see this written a number of ways. You can write it like this, it's exactly the same, or you can write it like this. Okay, whichever one you want to use is fine. But this is how we're going to find the area of a trapezium. So let's look at some examples. So we will calculate the area of these two trapeziums using this formula up here. So let's start with this one. So it's actually pretty simple. The area is just the perpendicular height, so that's the height at 90 degrees to the base, divided by 2, and then what goes in the brackets is the sum of the two parallel sides. So this will just be 6 times 38, 228, and the answer's in square millimeters. So let's look at this second one here. Now we know it's a trapezium because it has one pair of parallel lines. Four-sided shape with one pair of parallel lines is a trapezium. So we're going to use the same formula that we just used. So the area is going to be perpendicular height divided by 2. So this time the perpendicular height is one of the sides. And in the brackets goes the sum of the two parallel sides. So that should be 32. So this side here, the slant height, does not come into our calculations for area. It'd be very helpful if we wanted the perimeter, but not if we wanted the area. So I just put in my calculator, perpendicular height divided by 2 times the sum of the two parallel sides. So this is just 5 times 53, which is 265. In this case, will be meters squared. And then we're done. All right, the final thing we're going to look at in this video, we're going to use the area of a trapezium to find one of its dimensions. So let's try this question here. The area of a trapezium, 100 centimeters squared, perpendicular height 12.5 centimeters, one parallel side 9 centimeters. What's the length of the other parallel side? So let's have a go at drawing this to make it look a bit easier. So we know what a trapezium looks like. It's a 4-sided shape and it has one pair of parallel sides. So we know that the perpendicular height is 12.5 centimeters. It doesn't matter if the drawing's not to scale. See, the thing is that we don't know whether or not 9 centimeters is the longer or the shorter parallel side. It doesn't actually matter. I'm just going to put 9 centimeters here. We're still going to go about this the same way. So this is what we know. We know that the perpendicular height, when I divide it by 2 and times by the sum of the two parallel sides, I should get 100. So what that means is that 12.5 times the sum of the two parallel sides must equal 200. This times these two added together must equal 200. So when you divide it by 2, you get 100. So I need to find out what these two parallel sides need to add up to. So what do I times by 12.5 to get 200? Well, I could just go 200 divided by 12.5 on my calculator and I get 16. See, the two parallel sides must add to 16 because 16, what's in the brackets, times by 12.5 gives 200. And when you divide it by 2, you get 100. So, of course, that means the other parallel side must be 7 centimeters. This side here must be 7 centimeters. So why is that? Because when I find its area, if I add the two parallel sides, I get 16. Then if I times that by the perpendicular height, which is 12.5, I get 200. So when I divide it by 2, I'm going to get an area of 100. So the only possible value for this parallel side, this other parallel side, is 7 centimeters. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.